draw a right triangle. And then these formulas, go ahead, you know this one's a right triangle. That right there. With this one, it doesn't have to talk about. You don't need to write these numbers. Anybody see Emma today? Not here? No. Okay, so some of the vocab words that you had last week, and I think I put it in parentheses for you. I said that we classify it by sides, and then we also classify it by the angles. So if you were looking at this triangle, we classified it by the angles, we would call it a right triangle because it has a right angle. Okay. In order for it to be acute, it has to have what? Acute triangle. That's all of them have to be less than 90, right? Because technically here we have two of them that are less than 90. Okay. So all three would have to be less than 90. Okay, and then for obtuse, what's our, just one of them has to be obtuse, right? More than 90. Okay, so these formulas help us classify. So in this section, they're going to give you numbers, and you're going to go in that order. So don't like rearrange them to make C always be the longest side, okay? So this would be your A, this would be your B, this would be your C. Okay, so for right now, if A squared plus B squared equals C squared, then it's a right triangle, okay? If it doesn't, if the C is smaller, then we're gonna practice that down here. It's going to be either acute or obtuse, and if the C is bigger, then it's going to either be acute or obtuse. Okay. So with your calculators, we're gonna practice this so that you know how to put them into your calculators. And I'm just gonna scroll this down. Okay, so we're going in order. So if you square 15, so 15 times 15. Okay. And square your next one, because this was my A, this is my B. Okay, we're trying to figure out, does it equal what the square of this one is? So what this one is, when you put it into the calculator, because remember when you do this, it's really 15 times 15, unless you have the square button. That's what that means, not 15 times 2, right? So we go 15 times 15. And we get 225, which that one's the same thing, so 225. Okay, what this one is 15 rad 2 times 15 rad 2. You go 15 times 15 like normal, and then you multiply the radicals together, so rad 2 times rad 2 is really what? Rad, what's 2 times 4? 4, right? What is the square root of 4?
You said 2 times 4.
Did I?
Yeah.
Did I say that answer? Oh, sorry. Rad 2 times the answer ahead of time. I'm trying to send you a signal. Okay, rad 2 times rad 2 would be the rad 4. Square root of 4 is what? 2. So this, really what you do is you just drop one of these and take the square root off of it. So you're still going to go 15 times 15. And then it's times whatever number is underneath here. So times 2. Okay, so you're going to go 15 times 15 times 2. Which gives us, you guys are trying that 450. Okay, so we want to know, does it equal 450? Well, 225 and 225 equals 450. So that means that was a right triangle, okay, because the left side equals the right side. Okay, don't write this, I just want to make sure you're clear on this, because you're going to see this quite a bit. So say you had 10 rad 2, and you were supposed to square it. You're going to go 10 times 10 times 2. Okay, So you just drop that square root and only multiply it times once, okay? Because it really is rad 2 times rad 2, which is square root of 4. And square root of 4 is 2. It comes out. So it comes out as a whole number. Okay? All right, so now let's try the next one. So that was a right triangle. Okay, so we're practicing the next one. Okay, so we're going 11 squared, 12 squared, and we want to know, does it equal what 21 squared is? Okay, so 11 times 11, which gives me 121, and then 12 and 12 is 144, and then 21 times 21 is 441. So 121 plus 144 gives me 265. So obviously it does not equal that one. So that means that this one is the bigger one. Okay, so when you go back up to your formulas, which I know you have it on your paper, but this is just for those that aren't here today. When we go back up here, we're talking about this one right here because the c squared was bigger. So if this side right here, looking at this right triangle and trying to make this make sense, if this side gets bigger, what does it do to that end, that angle? It widens it out. So it makes it what type of triangle? Obtuse. Does that make sense? So when this line right here now gets bigger than what it was already, it spreads this out. It's going to make this angle bigger than a 90-degree angle because it's going to spread it out further. Okay? So that's why that makes that obtuse. So obviously you can guess what the last one is, which is going to be acute. So when this gets smaller, it's going to bring that in less than 90 to make that acute. So fill those two into your two formulas because you're going to need to refer back to them on which one's which. Okay. So let's try this last one just to make sure that we're understanding how to do that, and then we'll move away from these. Okay, so 13 times 13 is 169, and which obviously the next one's 169, okay? And then 12 squared is 144, so 169 plus 169 gives me 338. And remember that was my C, so my C is smaller. So if you wound up with something like that, then that would make it an acute triangle. You're good on how to figure those out? So if they're equal, it's a right. If the C is bigger, it's obtuse. And if the C is smaller, then it's going to be acute. Okay, so this starts us on our first problem. So this is number 59. Okay, now this time we're getting away from classifying it by angles. We are classifying it by the sides. So on sides, we had isosceles, which meant what? Two are going to be the same, right? And then we had isosceles and we had scalene, right? Where none of them, and what was the other one? Equilateral, which means all of the sides. Equilateral meaning all of the sides are the same. Okay, so when they give you the side lengths and they're all different, then that means it's going to be scalene. Okay, so some of these you'll just be able to glance at. Don't have to use formulas. You just need to know the rules about sides and. Okay, on scalene, what do you think is also true about the angles on a scalene triangle? They're all different. What do you think is true about isosceles? Two are the same. So the semblance, okay, and then equilateral, then that means all the angles are equal as well. Okay, so they might give you side lengths and ask you to classify it by angles. So you just need to know that's also true. So that could be scalene, okay, or classifying by the other one. Okay, next one. So on 60, you don't need to draw this, but just put symmetry question mark. Okay, so 60, symmetry question mark. Okay, so the two types of symmetry that you had rotational symmetry and reflectional symmetry. So rotational symmetry would mean that you would be able to take this shape and rotate it somehow where it looks exactly the same as the original, okay? So if I was looking at this one, okay, and I can hopefully, maybe let me earlier. No, it's not going to let me. Dang it, and then I clicked off it. Okay, so if I were to take this shape and rotate it this way, still doesn't look the same as the original. If I were to rotate it at 180 degrees, it still does not look like the original. So that would mean that this doesn't have rotational symmetry, because the only way you can get it back to looking like the original is when you get it all the way back to the beginning, okay? Because that would be 0 and 360. It can't be 0 and 360. It has to be at least something that's in between. So it does not have rotational symmetry, okay? Reflectional symmetry would mean that you could actually draw a line someplace. And if you can draw a line of reflection someplace and fold it on that line, could it match up? Yes. Okay, so this one actually has reflectional symmetry. So on 60, that's usually right. Because it asks you what type of symmetry. So just reflection. Okay, on the ones that have rotation, actually I have one on here, so we'll just wait until we get to that. Okay, next one. Do not want you to write, obviously, that whole thing. But this is the one that we just did. So number 61, you're going to write 15, 15, and 15 rad 2, which should look very familiar to you. So 15, 15, and 15 rad 2. Okay, so this is where our Pythagorean theorem comes in, the greater than, less than, blah, blah, blah. So it says a ship in calm seas steamed 15 kilometers in one direction, turned and steamed 15 kilometers in another direction, and then returned at 15 rad 2 kilometers back to its original position. The captain then plotted the ship's course on a nautical chart. She asked her first officer to look at the chart and describe the ship's path. Did the first officer describe it as acute, obtuse, or right? Well, we already did this one at the very beginning. So you have this written down. Remember what we do with A, B, and C. Okay, we square it, right? Square it. And then we figure out, is it equal to the third one? Which we've got to square that. And what was our answer? Right. Right. Okay, so that's the first part. And then it asks you another question. Okay? It says, then the second officer said she could further identify whether the path was scalene, isosceles, or equilateral. Isosceles, because you have two sides that are the same length. So remember when we said when they're all different, it'd be scalene, okay, or equilateral, which they're not because of that rad 2. So we only have two of the sides, right, that are the same, so you would say isosceles. So those will be worth 2 points. Classifying it by the angle and classify it by the sides. And the numbers are always in order, A, B, C. So don't flip them around. Good? Okay, so that's what you'll do on the story problem ones. There's a lot of story problems in this section. Yes?
Is it possible for an acute triangle to be scalene?
No, I don't think so. Because you would have to have one obtuse, one bigger than the other. In my head, know how that would be possible. Okay, number 63. Okay, so the question on this one, and obviously you're not drawing this one, that when it says if, okay, that means it could be no, and it could be yes. And then they'll also ask you, and this is what I was talking about on that first one, anytime it winds up being rotational symmetry, they'll sometimes ask you what the degree of rotation is, okay? So if we had this figure right here, and I would be able to rotate it, would I be able to rotate it and have it look like the original other than 0 and 360? Why?
Because the consonants. And
The consonants, the arrows are fine. If I didn't have the planet, like I didn't have like those shapes that are in there, the continents, right? Okay, I could actually rotate it and it would look like the original. Okay, at least 180. I don't know. I think when I put these in here, I might have stretched it this way, but at least this side and this side are the same length, right? So when I rotate this, that triangle, or the arrow that's right here, when I rotate it, if I were to rotate it this way, okay, it would wind up right there. So at least it has 180, okay? It probably was a 90, 180, because I stretched it to fit on to get that other one on there. Okay, but because of the continents, when you rotate that, these do not match up. So if I were to rotate this over to here, that's not matching up with what the original looks like. Okay, so this one has no rotational symmetry, so that you can't even answer that next one. Okay. And again, you'll see these on your worksheet when you get it. So it does not have rotational symmetry. So that's why it says if the figure has rotational symmetry, which it doesn't, then you would name the degree of rotation. So again, if the planet thing wasn't there, then you can actually say like 90 degrees, 180, okay, back to 360. Good? On that? Cool. Why it didn't work out? Okay. Because the planet. Okay, I don't know if that was my last one. That was the last one. Okay. So you don't have to do those ones. You have the answers to those when you get the notes.